I was cleaning and arranging my garage, getting ready for winter, putting some stuff in the back porch, and then when I was arranging stuff on the back porch, I came across this. It's a robot fish that, I don't know, my mom or my sister or someone gave me for Bud. Has like a robot wiggling tail. And I always wanted to do more with this because it's rechargeable and I think it detects motion and that's when it flops around. But, you know, the batteries are always going dead or it ends up under the washer or something. That was the easiest fish I ever gutted. Oh yeah, there's a power switch. I'm sure the battery's completely dead. I gutted the fish. Oh, I could put catnip in here. Oh, it looks like they thought about that. See, there's an extra pouch. I really screwed myself with that, what was it, Apple IIc? Don't turn it on. Take it apart. What's that, Bud? Are you whining? Do you want to eat the fish? Do you want to bite the carcass? Yeah, but then you'll like hide it under. It'll be lost somewhere in the basement. I won't know where it is. So I was thinking, at the very least, make this wired. And maybe put like an ESP8266 in it. What? You're interrupting my amazing video, Bud. Put an ESP8266 in it so I can make it controlled by the NSA Pringles can. Wow, I'm impressed how many screws are in this. It's got more screws than a $1,500 iPhone. Oh, that one's longer. All right. Oh, it's got a square shaft. Beauty. Oh, a lot of gears. All right, I don't think I want to mess with that part too much. Otherwise, you may have noticed I'm making fewer videos. Remember, YouTube is not my job anymore. Hasn't been for a long time. I only do it when I feel like it. Lately, I've been spending most of my time programming a new pinball machine for Spooky. Now, it's not, I didn't design the game. I'm programming it. I think it would probably be announced probably about a year from now. So probably like October or Christmas of 2023. Oh, there's a little microcontroller on it. Look at that. But yeah, it is a microcontroller. It's got a crystal. Microcontrollers? That could be worth a fortune. Fortune and glory, kid. Fortune and glory. Meanwhile, here comes Indiana Jones 5. Dr. Jones! Don't interrupt me. I'm in a rest home, eating soup. Dr. Jones, there's some magical thing we need your help for again. I don't do that anymore. Why don't you try my father? We already have. He's dead. So yeah, I find like these chip shortages are kind of depressing. Kind of makes me not want to do stuff with microcontrollers. But I went on DigiKey and I was like, what is the last available microcontroller? Now, recently there was a big shipment of Raspberry Pi Picos, more specifically the RP2040 chip itself. And I actually am working on a project with some Raspberry Pis for Midwest Gaming Classic. But, okay, notwithstanding that, the only like chip that's been consistently available in high quantities on DigiKey has been a ATmega 8L, which is a 8 megahertz version of, picture like a really, really stripped down Arduino Uno. Oh, but they have 82,000 of them. I wonder why nobody wants it. Like a squirt gun that shoots jelly. No marks on the chip. I ordered some, and then I also designed a breakout board from Oshpark. That battery's flatter than a pancake. I'd be willing to bet the safety tripped on the light post. Now if I unplug it... Whoa! Oh man, that charging circuit gets hot. Okay, now the battery's got... Its battery's been woken up from its slumber. So how does it turn on? Oh, there it goes. Oh, it is going back and forth. Oh yeah, okay, so it's got a... Oh yeah, if you look... Yeah, see there's two pins go into that chip, so that's a full H-bridge driving the motor. Yeah, for some reason in the back of my mind, I thought there would be like a cam that would go like to make it go back and forth, but I guess not. The thing is, yeah, you wouldn't even need a microcontroller if you did that. You could use like a capacitor and like a spring switch, like a mechanical vibration switch. You could use a timer and a switch. But yeah, I'm pretty sure it's a microcontroller. How is it deciding to turn on? Yeah, so power would be going there. I guess that makes sense. Got a resistor going to ground. Is that bleeding off some voltage? The can is ground, I assume. Ground, 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 ground. What do you call a cow with no legs? Ground beef. Do you think he saw us, Rex? Your jokes are terrible. I'm going to feed you to the dinosaur. Alright, yeah, so when it's switched off... Yeah, when it's switched off, the battery is being charged by USB, and then when you switch it on, the battery is going to the microcontroller. Let's turn it off before we do that, so there's no circuit. I will put the Antikythera mechanism over there. Yes, I did just reference the Antikythera mechanism. Okay, that's weird they've got ground going to one half of the crystal. It's weird. I'll try to zoom in digitally. One of the pins, they're actually isolating it with a silk screen. That's odd. So yeah, ground, power, H-bridge control, oscillator in, and then two other pins. And you've got this trace going through here, but that's probably going to the power. Yeah, so that's going to the H-bridge. Oh man, 2019. Oh, that was a halcyon age when we could afford to put microcontrollers inside of cat toys. I better not let Ford or Chevy find out that I have a microcontroller. They're going to send secret agents to my door and like, Bud, I'm trying to make you a Wi-Fi controlled fish. Don't you understand this? Oh, let's see. Oh, yeah, here we go. Here's an ESP8266 programmer. Everyone watching this channel knows what an ESP8266 is, so I'm not even going to explain it. And here's a broken out version. I mean, so you have your base module, right? And under this can is just the microcontroller and then the EEPROM where the execute and place code comes from. So I've got these two, but it's kind of a waste because all I really need are 2 pins. I need 2 pins and Wi-Fi. So even this one, even though it's only got, what, 8 pins, I think it has at least 2 I/O. It's been a long time since I did anything with these. Actually, when I first moved into my house, I made an automatic... I made this device that would open up one of my cabinet doors to reveal a garbage can. So I could say, Pringles can, garbage on, and then the door would open up like if my hands were covered with like flour or something. Oh, I just realized something. That's not a crystal oscillator. That is a kind of a reed switch. Yeah, so it's got a can with a very thin wire in it. And that's how it detects vibration and turns on. I actually used a switch like that in a project about a year ago that I designed for a guy for a company. Well, so will this thing be... I think it'd be cool to make it... Well, yeah, because if I make a Wi-Fi fish, I can make a thumbnail that says WIFI lowercase sh. Oh, well then in that case you should be able to shell into it. A Wi-Fi born-again shellfish. Shellfish! Hey, bud, you know, like when it's late at night and I wake up and go to the bathroom, but then you keep whining? You're being shellfish. Got a strange magic. Do, 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 do. Bud, I'm dismantling your fish. The one that's been laying on the back porch for like a year. I have a SOT23 breakout board adapter here. There we go. Do, 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 do. So, obviously I'm going to transplant this onto this little board. Bud, your automatic food bowl just went off. Go eat it. Got a strange magic. Dun, 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 dun. You have noticed recently my eyes have always had trouble seeing dark things, but I'm kind of definitely getting the idea that eventually someday what will fail and keep me from doing this kind of work. It's probably going to be my eyes before my hands. My hands work fine. Oh, I just bumped into the camera. My hands work fine, but I have no concept of space. Space is kind of limited in there. I think I'm going to put a right angle connector on this thing. Kind of like that. So I got to make sure that I wire it the right way. That should give us a little bit more space. Okay, I rigged together a right angle connector for that, and then I attached the H-bridge using that SOT23 adapter. I think I'll just chop apart part of this case so there's a... Yeah, that way the Wi-Fi can stick through the plastic and be able to get the signal. Yeah, you know, the Carpenters should have made a James Bond song. Well, I guess Carly Simon did. That's close enough. You know who should have made a Bond song? Was, the other person I mean was, Amy Winehouse. That would have been good. But then we got Adele. Skyfall, ready crumble, blah, 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 Skyfall. Why did everyone think that movie was so good? I actually like No Time to Die more. Even with the controversial ending. Yeah, Skyfall was like James Bond, Home Alone. Oh no, the bad guys are trying to take my home. I must defend it. That's what it was. Oh, you know what recent Bond movie I thought was really lame was the one before last, Spectre. Oh, so stupid. It's like, welcome to my solar-powered base, James Bond. Oh, it's exploding with gasoline flames everywhere. Well, that was so dumb. And then he sticks that really thin drill bit into his neck. That would totally have broken off. Oh, that movie was so dumb. Oh, and then at the end, it's like they go back to London and it's like in the ruins of like MI6. And there's all these like printouts of all the people from Bond's life. Because of course they have to keep reminding you that Eva Green was in the show. It's like, well, what did the bad guy... Because that was like one guy. What's his face? The guy who's always a bad guy. So, well, you know, he was Blofeld. So can you imagine? So what did Blofeld do? He goes to London, and then he's like in line at FedEx Kinko's before that scene, and then he's like, I must print out all these photos. But he didn't have enough money for color, so he's sitting there at FedEx Kinko's printing out all these printouts, and then he sneaks into the building somehow and posts them up, and then Bond takes down a helicopter on a boat at like 200 yards with a Walther PPK. Right. See, I know some people didn't like No Time to Die, but Spectre was just garbage. All right, I need to attach power and ground to the H-bridge. I know the GPIO on the ESP8266, sometimes they do different things, like they can affect a boot. Also, there should have been a resistor between the GPIO and the H-bridge here, so I'll have to add that. And then I'm going to just have this going to be USB powered. A couple reasons. Well, we'll get to the part where we put in the libraries, but when it turns on, it should connect to the network and then advertise itself using a JSON file as, hey, I'm a fake Alexa device. Oh no, I said the word. Yeah, but the other thing is, like, all of Bud's toys invariably end up in the basement. So I want this to actually be tethered with a USB cable, like a fish on a line. That way, he can't drag it behind the stove or something. Waste not. So I always keep these leads because I can use them for things like this. I like to use them for like power connections. So in this case, I'm going to take this one, I'm going to bend it 90 degrees and bring it over to the power pin. All right, now I'll do the same thing with the ground. It's raining outside, so I can't do any yard work. Of course, a new batch of leaves fell from the trees. Well, I did that last weekend too. Anyway, that's why I was cleaning my garage instead of doing leaf stuff. Okay, so I'm gonna put in these two surface mount 0805 1K resistors onto the I/O of the H-bridge. I'm gonna rotate this because I'm right-handed. Why is there an American flag? Because your condo is in America. Oh, that makes sense. Yeah, it was a little hard to get. Yeah, playing hard to get her, yeah? Trying to figure out the best pins to attach to the H bridge. There's only 4 I/O available, and 2 of them are RXTX. I assume that's used because this is obviously just a FTDI chip. It's probably used for a serial bootloader on the ESP8266. Blah 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 blah. 02. Connected to the flash button. Boot fails if pulled low. Okay, so as an output, it seems like it's okay. GPIO2 is high at boot. Connected to onboard LED. Boot fails if pulled low. Because I don't want, I don't want the fish to flop around just because it's booting. How long did it really take to boot? So yeah, I think I'm gonna do GPIO 0 and 2, which is gonna be these two. So I'm just gonna use some thin wire. All right, and finally, just got to attach the motor to the other side of the H bridge. It's a strange magic. Once I know this works, I'll probably hot glue the heck out of this. But until such time, I'm going to leave it open in case I have to adjust anything. And finally, I'm going to attach a USB cord for power. I think I'll probably also add some LEDs on here so I can test the code first, just to see if it, blink the LEDs in lieu of moving the motor. I'm actually deliberately using a full-size USB for this, so the cable's a little bit more robust. Oh, my instincts are saying, cover it with hot glue. Cover it with hot glue. And I'm like, no, I'll never join the dark side. If you will not cover it with hot glue, then perhaps she will. No! Da 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 da. Wait, that song wasn't in the original Star Wars. See, even if you just got like a dumb USB plug, sometimes they use, well, actually, oftentimes they use the data lines to negotiate. Even if they don't negotiate the power, there'll be like a pair of resistors or something on the power plug that say, oh, this is a charger of such and such type. Quick sanity check, I plug it in, and yes, this pin is high, but I guess that's probably because this thing hasn't been programmed. So I'm gonna try to do a blinking pattern first. Just, the blink, Bad boys, what you gonna do? What you gonna do when they come for you? I discovered that the programmer I had sitting in a drawer for years is kind of an old piece of junk. I actually had to add a boot button on the bottom of it. So I think there's like built-in LEDs, and like it's using the TX pin for this LED on the side. So I just have it flashing 0, 1, 2. Yeah, so this one must just be a standard power LED. It just stays on no matter what, the little red one right there. Yeah, the hard reset doesn't even work. You have to actually toggle the power manually. So one of the 8 pins is reset. I think this little blue built-in LED is actually GPIO 1, and it syncs instead of sources, which is why it was inverse of the other ones that I was blinking. So when this one went high, that one went low, and vice versa. So now I set it to GPIO 0 and 2 again, which should be these two. Man, this thing takes forever to load. Okay, hard resetting via RTS pin. Yeah, sure you are. All right, there we go. Oh no, the train's coming. I hear the train a-coming. It's rolling round the bend. I'm stuck in kitten prison, and I can't break free. That should be Bud's next song. I googled ESP8266 and then ALEXA. And then I came up with this site, Random Nerd Tutorials. I think this is the one I used, when was that, 2018 when I did that? This is going to tell you how to run the high-power devices. I don't really care about that. I just need the code. Okay, so Random Nerd Tutorials. The FOMO ESP. All right, the FOMO ESP library. It emulates a Belkin Wemo device. Oh, that's the kind I have, allowing you to control your blah, blah, blah with this protocol. Is it actually a library, or is it just some code? Because it should be like a web server, and then it would present a JSON file when queried, which would say, oh, I'm this kind of device. And then when you set it up using your phone app, it should allow you to add it. Easy ESP async TCP library. All right, well, I'll get these installed and then we can get to the code. I already had one of the libraries installed because, again, I did this back in 2018. And I did reinstall Windows last fall, but I did it without erasing my files, so it wasn't actually a clean format of the disk. Oh yeah, FOMO ESP. All right. FOMO. FOMO, fear of missing out. Credentials H files. This must be, okay, yeah, that's our password and Wi-Fi name. So I think we just give this a name like what we want the device to be called. All right, so let's see how this works. Serial, don't need that. Define LED yellow, ID yellow. There's a string here. That must be what the Pringles can calls it. Setting the LEDs. Okay, so we only need 2 of those. Sets up the Wi-Fi, creates a server, sets the port, enables it, adds device. Okay, this is the important part. ID yellow is a defined of a string. So it looks like you could add up to 5 devices to this and control it. Well, you could probably add more than, well, of course you could add more than 5 devices. That's probably all the I/O that it has. Okay, so there's a callback here, FOMO, onset state, device ID, device name, state, and value. Okay, oh, so value could be like, you know, set wall clock to 100%, and then value would come back as 255. Oh, so maybe we could use that. Like I could say, robot fish to 50%, and then it runs for 50 seconds. So is 0 the on state? Yeah, oh, maybe it's using like Linux. You know, like, well, I'm sure it is. Because, you know, like if you do a process in Linux, if it's successful, it returns a 0. Okay, a string compare, device name, ID yellow equals 0, then digital write, state. Okay, so that's where it's picking them out. Then there's a loop down here. Every iteration we handle it, and then every 5 seconds it just shows the free heap. A cheap way to detect memory leaks. Oh, maybe by checking the heap you prevent the leaks. All right, so we'll call it, but we won't print anything. Okay, so I think I also want to use millis for my own nefarious purposes. All right, so let's do this. Let's go back up above. All right, so we don't need any of this crap. Let's just do, we don't need any of this. Goodbye. Then there's all this. Got you, suckers. All right. We do want 2 pins. So I'm going to go pin mode 0 and 2, which is what we just set up. So that's going to be fish flop. Fish flop, like Waterworld. Remember when that movie was coming out there? They called it Fishtar, like Ishtar. All you kids out there, Ishtar was this famous flop movie in the 1980s. And for some reason, everyone hated Kevin Costner. He was like the Chris Pratt of 1990. So they were like, oh, they called Dances with Wolves Kevin's Gate because they thought it was going to flop, even though it was relatively cheap to make. And of course, it made $1 billion. So then Waterworld came around. They're like, oh, this is going to be the big flop. And actually, Waterworld did okay. The Postman was this big flop. Robot fish. So it looks like that takes a string. So, yeah, the Pringles can is going to call for, I assume, device ID. That would be the local device ID on this server, so it'd probably be 0. We'll just look for the name, I guess. State, I'm guessing it's going to be 0 to be on and 1 is off. I guess we'll see what happens in the value. So let's just get rid of all these else ifs here. Okay, let's get rid of this. And we're going to compare device name to robot fish. Oh, man, it's been a while since I programmed in this amazing Arduino IDE. Did they ever make a new one? If state equals 0, we'll do something. Well, actually, we could just pass. Yeah, we could just. Well, no, I want to use a Boolean. Okay. Fish fun? Yeah, fish fun equals true. Fish fun equals false. So we want to do as little as possible in this callback. All right, so now down here in the loop, let's go up here. Fish logic. Oh, it's like that Call of Duty game, remember? This game has the most advanced fish AI of any game ever made. Okay. All right, so we've got millis here. So they got a static. Okay, let's make our own static unsigned long last check equals millis. Well, this is a static variable, so this gets initialized once and then isn't updated again. So this code here only executes once. So then if millis, it calls millis. Millis tells you how many milliseconds have elapsed since the code started running. So basically it gets a snapshot, how many millis, and then if the current value of millis minus the last value is a delta of 5,000, 5 seconds, then it updates the value so it doesn't happen for another 5 seconds, and then it does this ESP3 heap, 3PO. 3PO, where could he be? Okay, so we'll do, I'll call it tick check. So tick check also equals millis. And then we'll do if millis does not equal tick check. So basically, tick check, let's say, okay, tick check equals millis, it's 1,000 milliseconds. Then the millisecond counter rolls over to, well, it doesn't round over. Then the millisecond counter goes to 1001. All of a sudden, tick check no longer equals millis, and that way we know a millisecond has passed. That's a better way of doing it than using the delay function because this is non-blocking code. The code continues to run while this logic executes. So we'll go tick check equals millis, just like the code down below did. Now you can't necessarily say tick check plus plus because millis might roll over. So it might be like, 4.2 billion and then it rolls over to 0. That's why you want to actually set it to the actual value. And then, so basically 1,000 times a second will go to fish logic. Actually, wait, no. 1,000 times a second, we'll check to see if the fish is active. If fish fun, now we could just do that, but if fish fun equals true, then do fish logic. Oh, I just thought of something. So if the fish gets turned off, you want to make sure the motors are off. So you have to set them both to 0. So we'll also need like a dead fish, which will just be a digital write, was it 0? So I'm just going to turn off both the pins. 0 and 2. So up here, so if fish fun gets turned off, then also call dead fish. Because the code might stop executing, but the pin, the high or low pin on one of the H bridges would still be high or low, which means the motor would continue to run. So regardless of the logic, we also turn off the I/O when the fish is disabled. And we probably want a fish state machine. I'll do these out here because this is where I feel more comfortable. Int? Do we really need an int? Oh yes, who cares? Int fish state equals 0. Let's see. Int fish timer 0 equals 0. Int fish timer 1 equals 0. Okay, I think I can remember those things. So really simply, fish logic. Okay. If, okay, when that fish was going like, so that's probably about 300 milliseconds per swipe. If fish timer 0, oh, actually, okay. So increment fish timer. If fish timer 0 is more than 300, wait, now that would increment every time. Now we want to switch the states, although I'm going to add more to it. Well, oh yeah, we could actually make his wiggling speed change too. Okay, just for now, I want to make the LEDs alternate when I talk to the Pringles can. I added a variable called fish dir. If fish dir equals 0, dir is that's what I use for direction. Been using these same stupid variables for like 40 years now. Wait, no, I've been programming that long. 37 years? If fish dir equals 0, then we'll do, see, this is where you want to make more functions because just, you don't want to like type this stuff a million times. Fish flop, which, okay, if which, yeah.
else that. See, gotta be really lazy when you program. Like only retype something if you absolutely have to. Like if someone puts a gun to your head and says retype this, and you're like, ah, oh, fine. I guess we have to make sure that we don't go too far in either direction because it would eventually bind up, if it doesn't go back to center. So that means we'd always want to revert fish flop which to 0, so after it restarts, it goes in the same direction again. Well, wait, but you'd have to know what direction it ended on as well. Maybe that's why they used a microcontroller. Okay, a fish timer 0 is more than 300. You probably also, yeah, I think most of the code is going to be driving the motor because assuming the Wemo stuff works. Yeah, because you probably want to have a dead period after. So you would stop both. You would move the motors, then you'd stop both motors. You wait a certain amount of time, then you'd reverse the motor. But again, we're just using LEDs right now, so it doesn't matter. So reset the timer. Fish flop fish dir. If fish dir equals 2, then make it go back to 0. And then, so fish flop if which, that's kind of confusing. And then dead fish turns them both off. I think, in theory, this should be ready to work, assuming that the integration works. Now, I'll have to add this as a device using the app on my phone, but I'm not going to cover that because why would I cover that?
I got the states reversed, but it seems to be working. Alexa, turn on robot fish.
Okay.
Alexa, turn off robot fish.
Okay.
All right, let's do the crappy reset since the programmer won't do it for us.
Okay, so if I imagine like if you said set it to 75%, if it was off, it would turn it on and then also pass that percentage over. All right, so let's say fish speed equals the value down here. If the timer is greater than fish speed, it will reset, which means it'll be inverse of what we think. So let's see. So that's going to pass. Okay. So it's going to pass 128 as 50%. So if we said 100%, it'd be 255. All right. So what we want to do is we want to do 255 minus fish speed. So we'll tell the Pringles can a percentage, but she'll, or it, will pass an 8-bit value to our device.
Alexa, set robot fish to 50%.
Okay.
Okay, so we have to assume, okay, so if we turn it on without a parameter, it's going to return 255 as the value. Well, it's moving so fast I can't see it because I cannot see at 500 hertz. But I thought it was 1,000 hertz. Yes, it changes 1,000 times a second, which means it goes on, off, which means the light's on 500 times a second, which is still faster than I can see. Alexa, set robot fish to 25%.
Okay.
Alexa, set robot fish to 75%. Alexa, instantiate robot fish.
From highbee.com. It's a type of catfish.
What? Oh, it probably passed along the most recent setting. Oh yeah, because I have that in my living room too. Like I'll turn on my lights and they'll be like pre-dimmed. Let's try. Alexa, set robot fish to 90%.
Okay.
Human, where's my robot fish? I'm working on it, bud. Oh, I made a mistake earlier. I didn't have a regulator, so I added this 3-volt regulator here. Well, 3.3 volts. Yeah, so let's get I'll solder the fish motor on. Then I'll plug in the module, then we should be able to give it a test. All right, powering it up. LED's on. Guess give it a second to connect to Wi-Fi. Alexa, turn on robot fish.
Robot fish isn't responding. Please check its network connection and power supply.
Well, it's on. Oh, I need pull-ups on the CHPD and reset lines. Why aren't there pull-ups built into the circuit board? Oh, well, that explains why it only works when it's in the programmer and not outside of the programmer. Okay, I added a pull-up to reset and switched although apparently only switched needed one. Want to hear my impression of every country song? It's okay to be a redneck. It's okay to be a redneck. It's okay to be a redneck. Also, women should be barefoot. All right, you think it'll work? Alexa, turn on Robot Fish.
Robot Fish isn't responding.
Now
Please
what?
check its network connection and power supply.
Open the pod bay doors, Hal. I still think this has something to do with the boot state of the pins. Like here's GPIO 0. If I disconnect it from the H-bridge, then it works. So now I'm going to connect the H-bridge after it's been booted. Alexa, turn off Fish Robot.
Okay.
Oh, I transposed the words, and she untransposed them. Alexa, turn off Fish Robot.
Okay.
See, that's the thing. There's all these different, like, boot states you can set with these pins, and you have to make sure you're not accidentally setting them. All right, for some reason, when this thing boots, the TX pin is high. So now I'm using the RX pin and GPIO 0. Alexa, turn on Robot Fish.
Okay.
Oh, finally. Alexa, set Robot Fish to 10.
Okay.
Alexa, turn off Robot Fish.
Okay.
Oh, man, so many gotchas. Look at how much time. That took me like 2 hours to figure out all these gotchas. Thankfully, we still have daylight savings time, so I gained an hour this morning, and now it'll be pitch black at 4 p.m. Alexa, turn on Robot Fish.
Okay.
All right, so it should always end on one extreme or the other. Darling, I don't know why I go to extremes. I think I might need some sort of heatsink on the regulator. But other than that, I think we can make it work. I just gotta hot glue everything in place. Oh, man. So many gotchas on that ESP-01 module. Oh, I forgot I was going to add a timeout to it. Yeah, the regulator does get hot. I'm trying to think of what I could attach to it. Attach something to that tab to sink some heat. I could maybe put some JB Weld on it and then put like a little heatsink on top, possibly, like one of these little guys. And then, yeah, I need to tweak the code, so right now it just keeps running. So I think what it should do after a certain number of seconds, it should stop and then randomly start again. As long as it's active, then of course if the user, being me, not the cat, says turn it off, then it just stops completely. All right. Let's ungut this fish. Ungut my fish. Say love me forever. Ungry these fish and none of the fish to get out of my life.
I added some more variables. Start flag, end flag, switch. All right, so case 0, I guess that'll be off. So we had those flags like fish fun or fish go, but I want to make it so the flags tell the logic what to do instead of being the end all be all. So I changed it to start flag equals true, end flag equals true. Okay, so case 0 means the fish is doing nothing. Fish is at rest, the day of rest. Okay. If the fish isn't doing anything and if start flag goes high, then we want to actually spool up the fish. So spool up the fish. Start flag equals false because we've serviced it. Yeah, okay. Fish state equals, I'm going to use 10. Case 10. Now you can also use strings, like, so if you wanted to have like, you could use strings for case as well. Oh, and fun fact, if the first thing you do in a case statement is say fish equals 12, you can't do an assignment as the first item in a case statement unless you do this. I don't know why. Oh, you can also do this. You can go case 9. See how that works? So either of these will trickle down and execute this code. All right, so I want to do a few other things. If start flag, okay. Oh, oops, look, I made a mistake. This needs to be inside of the if statement. Okay, also, let's reset fish timer 0 to 0. Oh, and then something else up here. See how I said fish speed new equals value? So I want to have a temporary value for fish speed so it doesn't affect motion that's already in, well, motion. So fish speed equals fish speed new. And actually, I want to do some scaling as well. So I'll probably have it be from like 300 milliseconds to 800 milliseconds. So I'll scale 0 to 255 to that. And actually, I could use the map function in Arduino to do that. Yeah, and map will automatically reverse it if need be. So yeah, let's just do that. Fish speed equals fish. Okay, so let's do fish speed equals map fish speed new, which is the number we just got from the Pringles can. Blah, 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 blah. Okay, so it's going to give us a number from 0 to 255. Let's turn that into a range of 200 and... Actually, no, let's go backwards. Let's go 750 milliseconds down to 250 milliseconds. Since a low millisecond time is a fast fish and 255 is the 100%, this should map correctly. So yeah, see how easy that is? But we only do it when we get a start flag condition. Okay, so we we clear the start flag, we change the fish state, we reset the timer, and then we have new fish speed. Actually, that should just be the timer limit. Fish timer limit. So maybe we won't even use speed. So I think we could probably just call this during the loop. I don't think it'll move in one direction, your favorite group. If fish timer is greater than fish timer limit, take it to the limit one more time. There's probably so much slop built into that gearing because they know the cat's going to affect its ability to flop around. I am probably way overthinking this. But the faster it moves, well, but the thing is, it's not moving faster, it's moving longer because all we're doing is we're turning the motor on or off. So I'm thinking about the pause time. Yeah, so the pause time should also scale. What can I do without IntelliSense? I need IntelliSense so I can be less intelligent. Map. Fish speed new. 0 to 255. Okay, so the faster it goes, the less pause time there should be. All right, let's go like 200 milliseconds to 500 milliseconds. Oh, wait, no, but it needs to go backwards. 500 milliseconds sounds like a long time for a pause. How about 300 down to 100? Now, remember, like here, we go fish state equals 10. It's not going to immediately do this because we're going to break out of it. But the next time we come back around, it will do this. So 1 millisecond will have passed. Fish state equals 20. So we'll use that as a rest state. Case 20. So when you program stuff, you have to think about like all the possible things that could happen. Like, oh, what if especially when the user's involved, like, oh, what if the user does this when this is happening? Or what if this happens, but this happens? So that's kind of what we're doing here. Whereas the user is me and a cat. If fish timer is greater than fish pause time, fish state equals 30. And this is just going to be this, but in the opposite direction. So 31. So really, you shouldn't reuse code. You should have functions, or you should have, doing this is sloppy. However, it's like make it work first and then make it efficient. Although in this case, I don't really care because it's a frickin' fish. Fish floppy the other direction. If fish timer is greater than the limit, go to state 40. Again, this is inefficient. I mean, I should have just had a state for the cooldown period, and then it keeps track of which way the fishtail is moving. Actually, that would be good because then you would, if the fish stops, which I'll get to in a second, if the fish stops, then you would know which way to go once you make it move again. Maybe I should just do that and get it over with. Like case 90. I had fishdir. Okay, so fishdir. If fish timer is greater than fish timer limit, so we're going to go to state 90, and then we'll do if dun, dun, fish dir is more than 1, then fish dir equals 0. Okay, so we jump to state 90. Yeah, we just go between state 10 and 90 until there's a break condition. Yeah, okay, so we don't need this because we copied it. We don't need this. Okay, I'm going to test this, but after we know this works, then I will put in the shutdown command. Actually, I'll just put it in right now because it's pretty easy. So we want it to finish a flop before it actually turns off. So what we'll do is, let's say the end flag gets set. We won't check anything here, but we'll check it at the pause. So if this does this, blah, blah, blah. Okay, so we'll also check if end flag is true. So we can just do if end flag since it's a Boolean. Turn off the end flag equals false. Then what do we call it? Kill fish? Dead fish? Dead fish. What are you doing? To call dead fish, and then fish state equals 0. So it will remember what its last direction was. So if it flips, and then you turn it off, and then you turn it back on, then it'll flop. Flip, flop, flip, flop. Oh, actually, if it's already running, let's wait until the cooldown period has happened before we check the state. Check start. All right, so let's say you're doing this, and then you change the speed. Okay, you get over here to the pause section, then it waits, it does the pause timer, and then it does check start and changes the state. Actually, we should do that last. Yeah. So these two things will happen no matter what. And then it'll jump to check start, and then it'll say, well, has the start flag been set? Okay, well, in that case, do these different things. So even though it's doing the same thing, it's changing fish state to 10 and fish timer to 0. If that weren't the case, if it was changing those flags to something else, then that would be good. So you have this default change here, and then you have an optional change here. Right. So basically, we do all the changes in the pause section, be it the speed or the flags to end it.
Alexa, turn on Fish Robot.
Okay.
I made it so it's going to slowly die. They say cats need to feel like they've killed their toys. Oh, now it's dead, but now it's going to rise from the grave in 3 to 8 seconds. Oh, the fish isn't dead! What the world needs now is more hot glue. It's the only thing that there's just too little of. Ungut my fish. Say you catch it tomorrow. Uncook this carp in my kitchen. You called in the lake down the road. I will give you a new body, and new troops to command. And nothing. You belong to me now. Bud, I've got a new toy for you. Ahem. Alexa, set robot fish to 100.
Okay.
It died, Bud. You killed it. I think we're going to need better strain relief. I'm going to put some empty Halloween candy wrappers inside the fish. Bud likes things that crinkle. That's a bad fish. Alexa, turn on Fish Robot.
Okay.
How to break your Xbox. I think you killed it, Bud. Alexa, set Fish Robot to 100.
Okay.
I wondered how long that would last. Bud, are you a YouTube star?
there you have it. We took a fish robot meant for cats. We used the ESP8266 module, and we made it a smart home fish. What cat could resist? I don't know how long that thing's gonna last.
Here's your sports update. In football, the Lions beat the Packers 15-9. In basketball, yesterday, the Bucks beat the Thunder
Alexa, stop.
8-9.
I don't need to know about how badly the Packers are sucking this season. Oh, that could be a good thumbnail.